Well, now we need to define the properties of our materials. There are two, yes, meat and cardboard. And here I have the properties of corrugated cardboard. Actually, COMSOL has a big list of materials built in with all the properties that you could need for your studies, but unfortunately meat and cardboard are not part of that list. So let's add the material. We have to add the materials as blank material, and then, well, automatically the first material is applied to all the domain. So we will add, for example, first the cardboard. So let's erase the meat. So that's the meat. Yeah, so now this first material will be applied only to the box, and I will write the label cardboard. Cardboard, and then, well, I need to define not all the properties, so just that. COMSOL is helping a lot with that because it's saying to us which properties we need to define. There are several options to add the properties, but for now, for cardboard we just need to add the values and the units. We know it are constant in our study. Well, the corrugated cardboard is slightly different from just cardboard. About the thermal properties of corrugated cardboard, if you want to check it, but basically thermal conductivity is this value, 0.078, and the units are the same. Let's check. Watts over meter Kelvin, yeah, and then density 700, and then CP, which is 1340, the same units. So our material now is defined, cardboard is defined, and then we need to define meat, which is slightly different. Let's add another material, blank material. Let's call it meat, and then will be applied to this part of the domain, and we need to specify these three values. So according to the literature, these are the thermal properties of meat. Well, basically we will not use the properties of meat, we will use the properties of Tylus MH1000, which are the same than the meat. And here is a very good study about that. As you can check, here we have the value of rho Cp over time, the multiplication of rho Cp. And here, near the freezing point, well, meat is really a special material because it doesn't have a freezing point, have an initial freezing point, yeah, because it is already a solid. So the concept of freezing in this kind of materials is slightly complex, yeah. So let's add the properties. First, Cp. Well, actually we have here rho Cp, so let's define Cp rho as 1, just as 1, and then define Cp as this value. These two terms are always multiplied, so it is the same for our problem. Then let's do it from here, basic definitions, and then interpolation. Well, let's put a label of this property, which is rho Cp, well, PCP, but it is representing rho Cp prop, and then let's look for the values. Here in my case, I have the values for each temperature in a file. Here rho Cp, let's check what is inside of the file. Well, here I have the value, the temperature in kelvins, and then the rho Cp value. So So let's open that and then import. We can plot the value just to check if looks like should looks. Yeah, here I have the values, and then I need to specify the name of the function, and it is really relevant because we will need it later. And there are a few options. For example, the interpolation method. For here we have some points. Yeah, so the values between 2 points is obtained how? Well, COMSOL ask. In this case, linear works good, but for example, we can select nearest neighbor, and then let's check what happened. Plot, and now it's a stepped function, as you can see, but it is really not as should be. So let's use linear, and then the extrapolation method. In our case, it is not relevant because I have the value of the properties for all the temperatures that we will need, so it is not relevant, but there are several options too. As argument, this function has only one argument, and it is temperature, and the unit is Kelvin. The units are Kelvin, and then the value for the output value is joule. Well, the units joule over kilograms times Kelvin. Let's plot again. The units will be put here. So now it is a relevant step in our material meet. We will specify our function. Here should be the same name that is in the function, yeah, CP, and the argument CPT, because it's a function of the temperature. So now it's ready, and let's add K now, and the same way, selecting basic and then interpolation, because I have a table with the values too. Let's look for the table. K, let's call the function K again, and then the number of arguments, yeah, it's just one. The label, I will put the label kprop, just kprop. Let's import the values, and then the name of the function K. And what happened if, well, here now is different, because what happened if we select, for example, non-linear as extrapolation method. Let's select, for example, well, not constant, let's select linear. Then COMSOL will assume some linear behavior beyond the limits of the data, yeah, but constant is good for us now. Let's check the units. T, well, actually the units are K Kelvin, but let's put another value just to check what happened. And the units for thermal conductivity is, well, are Kelvin, watts over meter times Kelvin. And then let's put here K as function of T, and let's see what happened. And well, actually COMSOL is saying that there is some problem with the unit or the input, so COMSOL is really helpful debugging this kind of stuff's problems. Let's put K, and then yeah, now all is working as should be. So let's save our project, and now our materials are defined. Let's check if they are being applied to the right part of the domain, here the box and the meat.